we need to solve this equation. So if you're going to go through and find the zeros or the x-intercepts, find the roots, find the solutions, what we need to do is come up with a method of breaking this down. Most of the time that involves maybe some factoring or maybe a formula like the quadratic formula, but in order to do almost all of those things, what we need to do is have our polynomial in standard form and equal to 0 on the other side. This one's like that already, otherwise that's where you would want to start. Get it in standard form, equal to 0. And then from there, if you try to go through and take a look at this equation, maybe try some factoring, that kind of thing, this does not fit any of the rules. We don't have a rule for factoring a 5-term polynomial. All that leaves us with is to try to do some synthetic division to find a solution. We want to do synthetic division, and if we get a remainder of 0, then the number that we divided by is a solution. But we don't want to just pick a number at random, so we are going to make a list of the possible rational zeros. We do that by writing down the factors of the the constant term on the top. There are a lot of factors of 36. On the bottom, we want to put all the factors of our lead coefficient, which is a 1, so thankfully the bottom part of our fraction, it's only a positive or negative 1. Pick any number on the top, divide it by any number on the bottom, and that gives you a possible rational 0. So you can do that at random, maybe do like a 9 over negative 1, which is a negative 9, and do synthetic division with negative 9. But remember that we are trying to find solutions which are also x-intercepts, so we can use a graphing calculator to narrow this list down even further. If you hit the y equals button on your calculator, type in this polynomial, and then hit graph. You get a graph that looks like that. And if you take a look at our graph, it looks like we have an x-intercept here, which is at negative 1. At least that's what it appears to be. And then also here at 4. So negative 1 and 4 are both numbers that are on my list, so I would start with those rather than some other random number. Let me try 4. I would rather divide by 4, I think. A nice positive number than negative 1, but both of those are probably about the same level of difficulty. We want to make sure that if we're missing any terms, we include a 0, so we have a column for that group. But we aren't missing any terms in this one, so just the coefficients. We have a 1x to the 4th, negative 3x cubed, positive 5x squared, negative 27x, and then a minus 36. Doing our synthetic division. I did get a remainder of zeros. So we are supposed to go through and solve. I'm going to start making a list of solutions. I just divided by 4, and I got a remainder of 0, so I know 4 is a solution or a root. And then from there, we can also use this synthetic division to do some factoring. Here's our original polynomial. We have 4 as a 0. That means that we could have factored the original with an x minus 4, and then the other set of parentheses would be 1x cubed plus 1x squared plus 9x plus 9. From there, you have some options. We have a 4-term polynomial here. We could try factoring by grouping, and that would actually work in this problem, or you could divide using synthetic division again. Well, it did look like -1 was going to be a factor. So I'm going to try to go through and do synthetic division again, but this time with -1. That's a pretty easy number to plug in. I already have my solution of 4 from this x minus 4, so right now I'm working on this 4-term polynomial and doing our synthetic division. I did get a remainder of 0 again, which means -1 is also a solution. I can add that up here on my list. That also means I could factor this again. So we already had a factor of x minus 4. We just divided by a -1. So that would give us a factor of x plus 1. And then the other set of parentheses would be this 1, 0, and 9, which is an x squared plus 9. All right, we have a solution of 4, we have a solution of -1. We need to keep solving this one. This, you would also have some options. A lot of times we try factoring when we get down a little bit further, after we've broken down the original a little bit, but this does not factor. It looks like it should, but this is the sum of squares, and there is no sum of squares pattern for factoring, so this does not factor. You could use the quadratic formula. It is a quadratic. If you did, a is 1, we have a 1x squared, b is 0 because we don't have any x's at all, and then c is 9. That would be another option. Otherwise, we have 3 things being multiplied together, that equals 0. We've already gotten our solution from this set of parentheses and this one, but what we can do is just set that last set of parentheses equal to 0. So technically, what we would be doing is x minus 4 equals 0, x plus 1 equals 0, and x squared plus 9 equals 0. But we already have our solution of 4, and we have our solution of -1. We got those solutions from those 2 synthetic divisions that we did up above. Those are not repeated solutions. Those are ones we've already found. But what we could do is we could solve x squared plus 9 equals 0. Grab another whiteboard here, since I'm almost off the edge. We could take x squared plus 9 equals 0, and we could solve that. Let me pull this down over the ridge. So this is what we do need to go through and solve. And again, you could use the quadratic formula to come up with the answers on this. Otherwise, we could solve this directly because we only have one term with an x, and it happens to be an x squared. So let me go through, and I'm going to subtract 9 on both sides. That would give me x squared is equal to a -9. In my next step, I want to get rid of the squared, so I would do the square root. Remember that when you do the square root, you can't forget the plus or minus. The square root of x squared is just x, and we need to simplify the square root of -9. The square root of -9, you'd want to break that down this way. You want to think of it like the square root of -1 and the square root of 9. The square root of -1, that is I, and the square root of 9 is 3. So a 3i is what we would get if we simplify that down. And we have the plus or minus in front. So we have 4 solutions. X equals 4, x equals -1, and then positive and negative 3i are the last 2 solutions. They do happen to be imaginary numbers, but that's okay. You can write that down as 3i, as -3i, or if you want, you could do plus or minus 3i also. That would be totally fine.